7. So this 7 has to be a superscript. So I'm gonna have to work on that. So this 7 has to be a superscript. So it comes up right there. So you can see 2 to the power of 7. This is what I'm looking for. So 2 to the power of this 7 is what gives you 128. And the same thing for here, for instance, we have 6, 2 to the power of 6 gives you 64. 2 to the power of 5, for instance, it gives you 32. 2 to the power of 4 gives you 16. 2 to the power of 3. So this is exactly what you're. So what we're looking for right now is this number. So how we get this number, I can just come and tell you the bit values are 128, 64, 32, 16, 8, 4, 2, 1, and that's all. But that's not what I am looking for. What I am looking for is how do we get these numbers, okay? So the decimal bit values for each of the bits that are in an octet, for instance, in a portion or a part of an IPv4 address is this. So we have 128, 64, 32, 864, 64, 32, 16, 8, 4, 2, 1. So that's basically what we are looking for, and that's the address that we are looking for, and that's it. So guys, I hope you're gonna follow these things to understand them. So now before we do anything, now we're gonna get out of this. So the bit values has to come this way. So I'm going to be using this. So these are my bit values. So I'm going to be using the tab key, 64, 32, 16, and 8, 4, 2, and 1. So basically this is what I am looking for right there. Let me just change this back to something bigger so I can see it properly. Sorry guys, I do not have all the tools necessary, so I'm just trying to be managing these things. So I hope you guys enjoyed the class. Alright guys, so this is exactly what I am looking for. So 2 to the power of 7 is the one that gave you this. So how do we convert a decimal number of, let's say for instance, a decimal number 1 into binary? Now this is what we are looking for. How do we convert this into binary? It is very simple. Now what you do is you try to subtract it from the left number, and if the left number cannot be subtracted from the value that is specified here, you put a 0. For instance, we ask, can 128 right here be subtracted? There is nothing like cannot but borrow, that mathematics syntax or whatever mathematics rules or whatever. It's not applicable here. So what you're looking for is if the number can be subtracted from the value in concern, you put 1. If it cannot be subtracted for that particular value, you put a 0. That means it cannot be subtracted. So now we ask, can 128 right here be subtracted from 1? Well, the answer is no. So we put 0. Can 64, that is right here, can we see this? Alright. Can 64 right here be subtracted from this one here? We say no, so we put a 0. Can 32 be subtracted from 1? No, we go. Can 16 be subtracted from 1? No. Can 8 be subtracted from 1? No. Can 4 be subtracted from 1? No. Can 2 be subtracted from 1? No. And can 1 be subtracted from 1? Yes. So it is a yes. So that means the binary representation of 1 is 0, 0, 0, 0, 0, 0, 0, 1. So that is the binary representation of 1. Now let's take a bigger number. For instance, let's take number 10. Okay, how do we convert number 10 in binary? Is very simple. Now what you will say is numbers from your left. Okay, right now I am facing my screen. I'm facing my screen. So my left is the number from 128, 64. It goes like that all the way to 1. So my value right now, what I'm looking for is number 10. So first, what I'm going to do is this first value on the left, can it be subtracted from 10? If it cannot be subtracted, the simple rule is just put a 0. Next, you're asking, is 64 being able to, can you subtract 64 from 10? No. You go. Next, can 32 be subtracted? No. Can 16 be subtracted from 10? No. Can 8 be? Yes. So 8 can be subtracted from 10. You put a 1. Now, when you do this, you have to subtract 8 actually. You're going to put minus 8. And that is equals to what? So, when you subtract 10 from 8, 8 from 10, you have equivalent, you have equals to 2. Now, these 10 and 8 are no more your action. Now what you left with is the 2, and that 2 is the number that you're concerned about now, because the 10 is already being subtracted, so your remainder is what your work is now. So can 4 be subtracted from that remainder? No, because 4 cannot be subtracted from the remainder of 2. But can 2 be subtracted from 2? Yes, we put a 1. And how much will we be left with? So we're going to put 2 minus 2 equals to 0. So there is nothing absolutely left. But can 1 here be subtracted from this 0? Absolutely, that is not possible. So it's a 0. So the binary representation of 10 is 0, 0, 0, 0, 1, 0, 1, 0. So that is the binary representation of 10. Now let's take another number that is higher. Let's say, for instance, we're gonna take number 31. Alright, so number 31 is what we are going with. So we just put here 31. Now number 31 is our concern right now. Now what we're asking is, can 128 be subtracted from 31? No. Can 64 be subtracted from 31? No. Can 32 be subtracted from 31? No. But can 16 be subtracted from 31? Yes. Now, if I subtract 16 from 31, so this I'm going to read. I'm going to say minus 16. Now, if I minus, or if I subtract this 16 from this 31, how much am I left with? That will be 15 left, right? It's going to be 15 left. So my answer is I'm left with 15. Now, 15 is what I am going to be concerned about right now. Not the 32, sorry, the 31 anymore. So I'm left with 15. Now the next thing is, can 8 be subtracted from 15? Yes. So I'm going to say again minus 8. So 8 can be subtracted from 15, and I put a 1. Now if I subtract 8 from 15, how much am I left with? 7. Now my value of concern right now is 7. Now, can 4 be subtracted from 7? Yes, 4 can be subtracted from 7. So I say 4 minus 7. How much am I left with? 3. So it can be subtracted, so therefore I'm going to put 1 underneath 4. So it has to go. This side and this side has to go together at the same time. So what you're doing is, next value is 2. So can 2 be subtracted? So now 7 is out. You're left with 3. So can 2 be subtracted from that? Yes, 2 can be subtracted from 3. And I'm left with equals to 1. So now I have to subtract, and I have to just say yes, it can be. So I put a 1. Now the next value is 1. Can 1 be subtracted from 1? Yes. So that is your binary representation of 31, and this is how you can convert any other number. All that you need to do is make sure you subtract that number from this. So we're gonna go. I'm just gonna continue with this. So I'm gonna cut the video into smaller portions. So the first thing that I want to make sure that you guys know how to do is how to convert this from binary to decimal and from decimal to binary. Next, that is it. So the binary representation of 31, or number 31, that is the binary representation of 31 is 0, 0, 0, 1, 1, and 3, 1. So let's take another number. For instance, let's take a higher number. Let's take, for instance, 224. 224 is what we are trying to convert to binary. Now we're going to ask ourselves, can 128 be subtracted from 224? Yes, it can be subtracted from 224. So now let's subtract it. So we're going to say here 224 minus 128, we're left with exactly 96. So yes, it can be subtracted, so we put 1. Next is, our value is never again 224. The value it concerned right now is 96 instead. So now we're gonna say the next value right here is 64 from the left. So we say, can 64 here be subtracted from 96? Yes, it can be subtracted, and then we will left with 32. So if it can be, what you do is put 1. Now we are left with 32. Now that 32, the next value right now from the left is 32. So what we do is we say, can 32 be subtracted from 32? Yes, 32 can be subtracted from 32. But what are we left with? 0. But still we have to subtract. So when we subtract it, we say, can it be subtracted? Yes. Now the value left is a 0. So all the remainder of the numbers here, 16, 8, 4, 3, 2, 8, 4, 2, 1, are all numbers that cannot be subtracted from 0, so they all remain as 0, because none of these numbers can be subtracted from 0. So the binary representation of 224 decimal number is 1110000. So that is what I want you guys. So I'll give you guys an assignment right after this one, and I'll ask you guys to do that for me before tomorrow, and then have it submitted immediately. Okay guys, so we just have to complete each and everything by day, so we cannot waste time. Now let's take a bigger number again. So I'm just gonna take 225 for instance. Okay guys, so let's take 255, or maybe 225. Let me just take 225, because that's how I just want to fix it out. Alright, so 225, let's take it this way. Can 128 be subtracted from 225? Now I don't need to even be subtracting right from here. If it can be subtracted, we just put a 1. If we put 1, now how much is left is 97. Now 97 is our value, because if I subtract this, I'm going to be left with 97. Can 64 be subtracted from 97? Yes, it can be subtracted. How much is going to be left is going to be 33 instead. Alright, 33 is my number. Can 32 here be subtracted from 33? Yes, it can be subtracted. So if I subtract this 32, that is this number here, if I subtract this number from this 33, I'll be left with just 1. Now can 16 be subtracted from that 1? It cannot be. Can 8 be subtracted? No. Can 4 be subtracted? No. How about 2? No. But can 1 be subtracted from 1? Yes, it can be subtracted. So immediately, this is exactly what we're looking for. So what you do is make sure that you subtract and then you subtract. So if you think getting these bit values, these are called the decimal bit values, okay? So each octet has to be worked out. So how to get this number is what I tried to show you guys in the beginning with those mathematics like 2 to the power of blah blah blah. But what we are looking for is this number. So if you can cram it, is the best thing. But if you cannot remember it, the best thing is remember the formula I just gave you in the beginning of the video, and then it will help you be able to remember some of these things. So I mean guys, I hope you understand this thing. Now let's try last number, just last example. What we're looking for is 255. So I just want to look at one thing here. If I add all these numbers together, it will not be more than 255. So an octet, that is a port or a portion of an I-4 address, is not more than 255 values. So if you have more than 255, you're not good. So what you do is, now let's convert this to 255 into binary. Can 128 be subtracted from 255? So let's subtract 128 from 255. We're left with 127. Okay, so it can be subtracted. We put 1 and then we move to the next value. Now the next value right now is 64. Can now 64 be subtracted from 127? Yes, it can be subtracted, and we are left with 63 for instance. So we are left with 63. So we said 64 can be subtracted. We put 1. Now the next value from the left, so we're gonna just get rid of all that because we're now left with 63 is our standing value. Next value here is 32. Now we say, can 32 be subtracted from this 64? Yes, it can be subtracted. Sorry about that. 32 can be subtracted, but when we subtract 32 from this, how much are we left with? Boom, we are left with 31 instead. So 31 is the value that is left. Good. Now we move to the next value, 16. Can 16 be subtracted from this 31? Bam. Yes, it can be subtracted. Yes, it can be subtracted. So when I subtract 16 from 31, I am left with how much? 15. Now that is it. Can 8 in concern here be subtracted from 15? Yes, it can be subtracted. So when I subtract 8 from 15, I'm left with 7. Next value is 4. Can 4 be subtracted from 7? Yes, it can be subtracted. So if I subtract 4 from 7, I have left with 3. And next value is 2. Can 2 here be subtracted? Sorry about that. Can 2 be subtracted from 3? Yes. If I subtract 2 from 3, I am left with 1. basically, can 1 be subtracted from 1? Yes, it can be. So the last is, if I subtract 1 from 1, I have 0. So everything is done right there. It is all complete. So if you have your IP version 4 octet, or a person or a part of an IP version 4 address all set to 1, that means the value is 255. So I hope you guys are going to enjoy this video. Now let's do the reverse of this. Now let us assume the simplest is we have a binary value. Okay, we have a binary value of 0001111. So this is the one that we have to convert into decimal. Now we need to know how much is this in number, instead in binary. You want to know how much this is in number. What you do is put each of these bits under a value. We have 8 bits here and we have 8-bit values here. So 8 digits, 8 binary digits and 8 numbers right here. So we have 0, we put 0 under here. Right, so we have 0, 0, 0, next is 1, next is 1, the next one is 0, and all the rest are 1 and 1. Now, how do we get this? The answer is, how do we convert this binary? We just have to make sure that we get the bit values that have 1 underneath them, and then we add them together to get us the exact value in decimal format. So it's simple. The numbers that have 1 underneath them is 16 plus 8 plus 2 plus 1. So these are the numbers that have 1 underneath them. So if we add this together, how much do we have? So 16 plus 8 here is 24. 24 plus 2, 26, and 26 plus 1 is 27. So exactly the binary representation of decimal representation of 0001111 binary is 27. So it's very simple. Any value or any binary number that you have, to convert it to decimal, it's very simple. Just put the bit values, the binary numbers under the bit values in concern, and then you're good. All right, so let's take another example. For instance, I have 111011101. So this is the number that I am looking for. This is the binary digits that I want to convert into binary, into decimal. So it's very simple. What I do is 1. I have 1 here. I have 1. I have 1. I have 0. I have 1. 1. I have 0, and I have 1. So that is this number. So this number, this digits is what I have here. Those binary bits, or those binary bits are what I have here, and I just put them underneath these numbers. So 128, 64, 32. So now, how do we convert this into binary, into decimal? It's very simple. Numbers that have 1 underneath them, add them. So I have 1 underneath 128. I have 1 underneath 64. Only numbers that have 1 underneath them, you add them together. Those with 0, you ignore. So here, another number is 8 has 1. 16 does not have anything. 16 has a 0, so we're just going to have to ignore 16. The next thing is plus. The next value here is 4. 2, no, it does not have anything, but 1 has. So we're just going to have to add this together. So when we add this together, 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 8 is 224 is 232. 232 plus 4 is 236. 236 plus 1 is 237. So the binary representation here is, the decimal representation of this binary digits or bits is equals to 237. So guys, I will see you guys in my next video. I hope you guys was gonna do, but before we go, I take a leave of you guys, I'm gonna just give you a few assignments. So what I want you guys to do for me is convert these following numbers to binary. We have 9, 23, 45, 127, 227, and 245. So I want you to convert these numbers for me into binary, and one more, convert the following binaries. So I just supposed to put something here. Convert, I just have to put that, the following decimal, supposed to be decimal values into binary. That is 1. And here we're gonna convert that's supposed to be the following binary bits to or into decimal. That's one thing that I like doing. So those binary bits would be 0 0 0 1 1 0 1 1. No, I did that just now. 1 1 1. So I think those are 8 bits. So I have 1 1 1 0 1 1 1 0. Another one will be 1 0 1 0 1 0 1 0. So guys, this is gonna be your assignment, and I think I'm gonna have to post this on your WhatsApp page so you can convert those ones, so you can just follow. And if you have any questions, please ask me, and I'll be more than willing to respond to your